The second method to make location decisions is called the load distance model. Actually, it's more of a procedure and less of a model, but let's just have a look how this works. So the load distance model evaluates location alternatives based on weighted distances. So on the one hand, we always look on the distance between a potential location to all the existing locations, for example, to all existing customers. And on the other hand, we always look at the amount of goods that have to be transported from the new potential location to the existing locations. So if we are, for example, the company that produces Mountain Dew, and we are looking for a single new warehouse location that should be used to provide Mountain Dew to our customers, which are supermarkets, then we look at the distance of the location to our customers, and at the same time we look at the amount of transport that we have to do from the new location to the existing customer. The reason is, of course, we have many different customers. Maybe we provide big supermarkets, big hypermarkets with our products, but on the other hand, we might have also a number of smaller, very local supermarkets that we also need to provide with our goods, but we deliver a much smaller amount of bottles to these supermarkets. So we want to combine both distance and the load, and the goal is to identify a location that minimizes the total load that is moved over a given distance. And the idea is that the distance between two facilities with a high amount of load between each other should be as low as possible. If we have many transports, many loads between two locations, they should be as close as possible. When we have a small number of loads between locations, it is not so important if they are far away. Now, the load distance model works as follows. We have here the mathematical notation, the formal notation. Again, the potential locations are numbered from 1, 2, 3, 4 to n, and the existing locations, for example, existing customers, are numbered from 1 to n. And for the existing locations, I use the index j, and for the potential locations, I use the index I. Now, what we have to do for each potential location I, we calculate a score. This score is called load distance score of the location I. And the score is calculated as follows. We select one I, for example, location number 3, and then we calculate this formula. Big sigma, our sum sign, our summation sign, and we start with the index value 1 for j, and then j change its value in each iteration until it reaches n. So if I is 3, our location number 3, then this reads L of 3, 1, multiplied with the distance between 3 and 1. And then we sum up all these terms to get the load distance score of the given location I. Sometimes I use a shortcut for this location when it's clear which numbers are meant with the index j, and I can also write it like this, and omitting the upper summation bound and the starting value, then it just means I sum up over all values that j can have. And since I have defined it here in the beginning, this is useful alternative, a shorter alternative to this one, but maybe as a beginner try to use this more complete notation. And at the end, we compare the scores for all our locations, and the location with the lowest score is considered our best location. Let's look at some more details. First of all, we need to measure the distances between our potential locations and the existing ones. Now the first problem arises: how to measure these distances. Of course, we could take an Euclidean distance via Pythagoras. We could try to use the real distance via entering the data in Google Maps, for example, and then using the real road network. But we can also use the rectilinear distance, which is quite simple to calculate. And if you are dealing with many locations in a similar road network, then this is a very good approximation that makes life much easier. So look at this map from the bird's eye point of view. We have here the x-axis. The distances on the x-axis are given in miles because this graphic is from an American textbook. We have here the y-axis, although the distances are given in miles, though the point B is 10 miles on the x-axis and 15 miles on the y-axis. Now the distance between point A and B, we can either use the road network, which is not shown in this map. We can use the Euclidean distance, so the direct distance between both points, or we can use the rectilinear distance, which can be quite simply calculated. Rectilinear means we just use west-east movements or east-west movements and north-south or south-north movements. So in order to reach the point A, we can only go on the horizontal or only on the vertical axis. And then the distance between A and B is the distance of this dashed blue line. The length of this dashed blue line is the distance between these points in the rectilinear measure. So the distance between point A and B is defined as the absolute value of the difference between the x-coordinate for point A minus the x-coordinate for point B. This gives us this distance, the length of this segment, and we add up the distance on the y-axis, again the absolute value of the difference between y of A minus y of B. And in the example this would be 30 minus 10, 30 the x-axis value of A minus 10 the x-axis value of B plus 40 minus 15. 40 is the y value of A minus the y value of 15, though the total distance is 45. It should be miles, not kilometers. So this is the way how you measure the distance, and if you have the coordinates of the points, you can quite straightforward calculate the distance. The second step is in identifying the loads. So how much do we need to transport to each existing location? So for each existing locations we need to have a load value. This is here given as Lij. And this parameter means how much do we transport from location I to location J. In many cases, location J has a fixed demand, and if you are only going for one new potential location, then we only need to focus on the demand of the location J. In step 3, we now calculate the actual load distance score, LD. We do this for each location, and the load distance score is the summation of the load that has to be transported between location I and J times the distance between location I and location J. We do this for every location, and the location with the lowest load distance score is our winner. This is the best location that we have identified.